Lesson 19.2 Task 2. Convert from standard form to vertex form. You can use the techniques of completing the square to convert the standard form of a quadratic equation f of x equals ax squared plus bx plus c to the vertex form f of x equals a times x minus h squared plus k. Alright, so if we look at the steps to do this, we start with standard form, ax squared plus bx plus c, and I'm just going to talk through this because this is a little complicated because it's written in algebraic form and not necessarily care that you can do this with these variables. What we need to do is understand the steps so that you can do this with an actual equation with numbers, okay? So the first thing you want to do is factor in a out of your variable term. So out of your quadratic and linear term, we're going to factor the a out. That's just because in order to complete the square, your quadratic term has to be a perfect square. So if we factor the a out, that makes this x squared. That is an easy way to complete the square. All right, so we're going to add and subtract b over 2a squared. So remember, when you're completing the square, you take b, you half it, and you square it. And the reason we've got a in here is because we got to make sure that a is factored back into the equation. So we did that some with completing the square as well. So the reason we're adding and subtracting it is because we're working on one side of the equation. When we completed the square before, we added the same term to both sides of the equation because we were solving to get an answer. This time we're just manipulating the equation. We're rewriting it. So if I add 2 and then I subtract 2, I get 0. So I haven't actually changed the equation. So this is just another way to manipulate the equation and change it to rewrite it. All right, so once you add the part that you need to complete the square and you subtract that part as well, then you're going to distribute the a to this part here, because what we're doing is we're going to pull this out and we're going to use this inside trinomial to rewrite in factored form, because we completed the square to make sure this can be written as a quantity squared or a binomial squared, which is the whole reason to complete the square. So you're going to distribute the a to this part so you can move it out. And then you're going to rewrite this in factored form. So we write that in factored form. It's going to become x plus b over 2a squared. And then again, we move this other part to the outside. So that's why now after squaring this whole term and multiplying by a, it gets simplified to this. All right, and then vertex form, they're just cleaning this up by, combining this stuff. So we're going to have a times x minus h, this becomes our h, squared plus k. So if you rewrite vertex form using a, b, and c, our variables from standard form, we now can see that this is our h and this is our k. And again, that's a little complicated, but just understand what the process is. You're using completing the square to go to vertex form. Vertex form and standard form are equivalent. They're just two different ways to write an equation. All right, so number 2 says the vertex of a times x minus h squared plus k is hk. So remember, minus h plus k, so opposite of hk. Hk is our vertex. All right, so you've seen standard form rewritten in vertex form. What is the vertex in terms of a, b, and c? So it'd be negative b over 2a. And then this part here is your y. So this would be our x and y, or in vertex form, that's our h and k. All right, use the results above from the function to complete the statements. The axis of symmetry for the graph is negative b over 2a. You can see that was our x. This is the same as our x-coordinate from before. All right, complete the statement to evaluate the vertex form. All right. All right, this is not something we're going to spend much time on because I'm going to show you an easier way to look at this. All right, so basically what we're looking at here, this is our axis of symmetry, x equals negative b over 2a. We do need to know that how to find that. So x equals negative b over 2a. And then what this is basically saying is take your vertex and subtract a number to find a point on the left. Take your vertex and add a number to find a point on the right. And if you subtract 2 and then you add 2 from the vertex, you're going to get 2 points that are symmetric. When you graph it, it will be a reflection across the axis of symmetry. So again, this is written in algebraic form. It looks very confusing, but that's basically all they're doing. So it says which statements are true for the expression you just found and for the graphs shown. Select all that apply. All right, so the resulting expressions are the same. That's true because if you look at this, when you plug it in, these are going to be the same y values. So those will be the same. And then it says they're opposites. No, they're not opposites if they're the same. The 2 points are reflections across the x. Well, they don't reflect across the x. This is the x-axis. So it doesn't reflect across the x, but it does reflect across the axis of symmetry. So that would be this one. And they are symmetric with respect to the axis of symmetry. So symmetric means they are basically reflections of each other. So this one reflects to here. So that would be the correct answers there. And then the last one says symmetric to the y-axis, and that is not true unless your vertex is on the y-axis. So that would just be a special case. Complete the statements about the zeros of the quadratic function. To find the zeros, you can set the expression equal to 0. Then the expressions you obtain for the zeros in simplest form are the same as the quadratic formula. So if you set that equal to 0 and solve, you're going to get the same answer as to if you use the quadratic formula. All right, so it says rewrite f of x equals 2x squared plus 6x plus 5 in vertex form. All right, so here's an actual example with numbers that we're going to look at how to use the process above to rewrite this in vertex form. So we have y equals 2x squared plus 6x plus 5. The first step, remember, was to factor the a out of the first two terms, your variable terms. So factor an a out of x squared. And your x, your linear term, so 2 out of 6 is 3x, and then plus 5. All right, now we're going to use completing the square in order to rewrite this. So we're going to have 2 times x squared plus 3x, and then we're going to do plus, and we're going to do minus. And the reason we're doing that, again, is because if we add 2 and subtract 2, not saying that 2 is going to be here, if we add and subtract the same number, then we're just manipulating the equation. We're not actually changing the equation. So we're just trying to rewrite it in vertex form. All right, so remember how to complete the square. We take b, we half it, and we square it. So we're going to take b, we're going to half it and square it. We're going to put the same thing here, half it, and square it. All right, and the reason we do that, again, just trying to keep the equation the same, we're just rewriting it. All right, now we need to take the a and distribute it to this term so we can move it out, okay? So let's take 2 times, we're going to have x squared plus 3x plus, I'm going to go ahead and rewrite this as 9 over 4. And then I'm going to take the 2 and multiply it by the negative 9 over 4. I'm just squaring both the numerator and the denominator here. So 3 halves squared, 3 squared is 9, 2 squared is 4. And the 2, because this was rewritten and this is in parentheses, because we factored this out, we have to multiply it back in when I move this outside the parentheses. So again, just to keep it equivalent, that's what we have to do. All right, so now we have a perfect square trinomial. We know we do. We can rewrite that in factored form now because we completed the square in order to make that a perfect square trinomial. So that's now going to be x plus 3 halves quantity squared. All right, and then we've got 2 times negative 9, so that's going to be negative 18 over 4, plus, if I rewrite this as something over 4, it would be 5 over 1, multiply, that would be 20 over 4. 4 times 5 is 20, so I can just rewrite 5 as a fraction so I can combine these two fractions to write it in simplest form. So I'm going to have 2 times x plus 3/2 squared minus 18 plus 20 is 2 over 4, and 2 over 4 reduces to 1/2. All right, so we can see that the vertex is going to be opposite h and k. So we can now answer this question. So we can say rewrite 2x squared plus 6x plus 5 in vertex form. That's what we've done. This is vertex form right here. Which statements are true about this function and its graph? Select all that apply. All right, so it's going to be 2 times x plus 3/2 squared plus 1/2. So that one is true. And then it's going to be, the vertex is going to be negative 3/2 plus 1/2. That one is also true. So the vertex can't be these others if that's the only one that works. All right, so that is all for task 2. We will do some more practice on this, so please join me for the next video. If you have any questions on this, please let me know.